Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. In this video, we are going to discuss the second part of the preparation and standardization of different standard solution. In previous video, in detail, we have discussed how to carry out the preparation of oxalic acid and standardization of it, as well as of the 1 molar sodium hydroxide. If you are coming first time to this my YouTube channel, you can watch my previous videos also. In this, and if you like the content of this my channel, then you can subscribe to my YouTube channel. So let's begin with our today's session. Before discussing our today's session, we will see first the learning outcomes of this session. Means after watching this video, what you should understand. So after this session, all students will be able to explain how to prepare and standardize different standard solution. In previous video in detail, we have discussed about the how to prepare or what is the meaning of standard solution. The solutions which are having the known strength, they are known as the standard solution. So in this video, we will be discussing how to carry out the preparation and standardization of hydrochloric acid and then sulfuric acid as well as the nitric acid. So let's first start with the 1 molar hydrochloric acid. The procedure is same, just I will explain in short. Here the molecular formula of hydrochloric acid is HCl. If we convert it into molecular weight, it becomes 36.5 gram. That is, the hydrogen is having a 1 and chlorine is having 35.5 as atomic mass. So addition of both the atomic mass will convert into it a molecular weight. Then first we will see how to carry out the preparation of the hydrochloric acid, that the 1 molar hydrochloric acid. We have to carry out the weighing of, we have to use 85 ml of hydrochloric acid and we have to dilute it with the help of the quantity sufficient to produce the 1000 ml of water. Means first we are going to measure the 85 ml of hydrochloric acid, which is to be transferred into the conical flask, volumetric flask, and in that we are going to carry out the addition of the water to produce the 1000 ml. Now here you can see, in case of NaOH, we have taken 40 grams of NaOH into the 1000 ml of water, because 40 is the molecular weight of the sodium hydroxide. But here you can see molecular weight of hydrochloric acid is 36.5. Still we are going to take the 85 ml of hydrochloric acid. Now why this is the difference? Here this is the molecular weight which is represented into the grams, that is the 36.5 gram. If we take 36.5 gram into the 1000 ml, then it will becomes 1 molar. But as we know, hydrochloric acid is available into the liquid form. We have to convert the how much volume of hydrochloric acid that is necessary to take into the 1000 ml. That's why by performing different calculations, we come to conclusion that we have to take 85 ml of hydrochloric acid. Now why 85? Because the whatever the concentrated hydrochloric acid that is available, it is of strength 36%. Means 36 ml of HCl is present in 100 ml of the solution. Means if I take 100 ml of hydrochloric acid, only 36 ml of that particular is present in the HCl. But the specific gravity of hydrochloric acid is 1.18. So if we multiply 36 into 1.18 gram, that is equal to HCl that is present into 100 ml. So to prepare 1 molar solution of HCl, we will require the 4 to 4.8 gram of HCl in 1000 ml. First quantity that we have calculated, that is the 42.4 gram, that is for 100 ml. For 1000 ml we will require the 4 to 4.8 gram of HCl. And by multiplying with the help of the different factor calculations, this value becomes 85 ml of hydrochloric acid. That's why we have to take 85 ml of hydrochloric acid into the 1000 ml to get the 1 molar hydrochloric acid solution. Now we will see how to carry out the standardization of hydrochloric acid. First we have to weigh accurately about 1.5 gram of anhydrous sodium carbonate. Here this sodium carbonate is acting as the primary standard, which is previously heated at 270 degrees Celsius for 1 hour. Then dissolve 100 ml of water, add 0.1 ml of methyl red solution to it, which is acting as a indicator, and add the hydrochloric acid slowly from a burette with a constant stirring until solution becomes faintly pink. Here also we are going to carry out the neutralization reaction, where anhydrous sodium carbonate is acting as a basic compound and hydrochloric acid is acting as a acidic compound. At the end of reaction, where we will get the salt formation, and as soon as there will be formation of completely salt will takes place, our conical flask will be consisting of extra amount of hydrochloric acid, and that's why the solution becomes faintly pink. Heat the solution to boil and continue the titration. Heat again to boil and titrate with as necessary until the faint pink color is no more longer affected by continued boiling. In this way, standardization of hydrochloric acid is carried out. So this is about the hydrochloric acid. Then we will see what is the reaction. Here also you can see 1 mole of sodium carbonate is required, where 2 moles of hydrochloric acids are required in this particular reaction. So that for factor calculation we have to consider 2 moles of hydrochloric acid. So 2 moles of hydrochloric acid is equivalent to 1 mole of anhydrous sodium carbonate. So 2000 ml of 1 molar hydrochloric acid, because 2 moles are required, that's why we have multiplied it with the help of the 2 into 1000 ml, that is equal to 105.99. So this is the molecular weight of sodium carbonate. So if we divide it by 2000, so it becomes 1 ml of 1 molar HCl is equivalent to 0.05299 gram of sodium carbonate. Next solution that we are going to see is sulfuric acid, which is having a strength of 0.5 molar. Molecular formula of sulfuric acid we know, H2SO4. So if we convert it into the molecular weight, it becomes the 98.08. So for the preparation, we have to carry out the addition of the 27 ml of sulfuric acid to 1000 ml of water and allowed to cool to the 25 degrees Celsius. Here, similar to HCl, as sulfuric acid is having available in the liquid form. So we have to take the 27 instead of 49.8 gram, we are going to take 27 ml of sulfuric acid in 1000 ml. Now how to carry out the standardization of it? Weight accurately about 1.5 gram of anhydrous sodium carbonate. Here also same primary standard is utilized, that is the sodium carbonate, which is previously heated to about 270 degrees Celsius for 1 hour for removing the moisture content and whatever the water of crystallization that is present. Then dissolve 100 ml of water, dissolve that quantity into the 100 ml of water and add the 0.1 ml of methyl red solution. Then add sulfuric acid slowly from a burette with constant stirring until the solution becomes faintly pink. Now one thing about the sulfuric acid, there is a difference between the molarity and normality, because equivalent weight of sulfuric acid is half of the molecular weight. So 1 mole of sulfuric acid is equal to 0.5 equivalent weight of that particular sulfuric acid. That's why there is a difference while we are going to prepare the normal solution and the molar solution. Then heat the solution to boil, cool and continue the titration. Heat again to boil and titrate further as necessary until the faint pink color is no longer affected by continued boiling. So this is the reaction. 1 mole of sodium carbonate is required for 1 mole of H2SO4. Further factor calculation, 1 mole of H2SO4 is equal to 1 mole of anhydrous sodium carbonate. So 1000 ml of 1 molar H2SO4, that is equivalent to 0.005.99 gram of sodium carbonate. So final factor becomes 1 ml of 0.5 molar H2SO4, that is equal to 0.05299 gram of sodium carbonate. So this is about the preparation and standardization of sulfuric acid. Next, how to prepare nitric acid, that is the 1 molar. Molecular formula of nitric acid is HNO3. Molecular weight 63.01 gram. For preparation, we have to take 63 ml of concentrated nitric acid and we have to add water sufficient quantity to produce the 1000 ml. For standardization, we have to take 2 gram of anhydrous sodium carbonate in 50 ml of water. Titrate with the nitric acid solution using methyl orange solution as an indicator until the solution becomes reddish yellow. Boil for 2 minutes, cool and continue the titration until the reddish yellow color is restored. Then reaction we will see. Sodium carbonate is addition of sodium carbonate plus, sorry, here there is a mistake, sodium carbonate plus HNO3, that is equivalent to, which leads into the formation of sodium nitrate and the bicarbonic acid, which on further will be converted into the water and the sodium carbon dioxide. Factor calculation: 2 moles of HNO3 are equivalent to 1 mole of anhydrous sodium carbonate. So 2000 ml of 1 molar HNO3, that is equivalent to 105.99 gram of sodium carbonate. So final factor: 1 ml of 1 molar HNO3, that is equal to 0.05299 gram of sodium carbonate. Then perchloric acid in glacial acetic acid solution. Molecular formula perchloric acid is HClO4. Molecular weight is 100.46. For preparation of 0.1 molar perchloric acid in glacial acetic acid, we have to mix 8.5 ml of perchloric acid with 500 ml of anhydrous glacial acetic acid and 25 ml of acetic anhydride. Cool and we have to add the anhydrous glacial acetic acid up to the 1000 ml. Here you can remember, instead of using water, we are going to use the glacial acetic acid solution. Allow the prepared solution to stand for 1 day for excess acetic anhydride to be combined and carry out the determination of water. Then for standardization, weight accurately 0.35 gram of potassium hydrogen phthalate. Then add 50 ml of anhydrous glacial acetic acid. Add 0.5 ml of crystal violet solution and titrate with the perchloric acid solution until the violet color changes to emerald green. Perform a blank titration determination and make necessary correction. This is the reaction. For that, this is the perchloric acid which is present against the primary standard, that is the potassium hydrogen phthalate, which leads into the formation of dicarboxylic acid. So here we have seen in detail about how to carry out the preparation and standardization of the different standard solution. If you like the content of my channel, please like my videos, share with your friends and subscribe to my YouTube channel. Thank you.